Hello and welcome to this video where we're going to be talking about how to combine datasets together. We're going to talk about how to do it in a few different ways, so you sort of have multiple tools in your tool belt. And combining datasets may sound boring, but it's really important. And if you do data work, you're going to do it a lot, even if you're not using different data sources. Then you're gonna need it for some operations sometimes. Yeah, that's for a later video, but yeah. So it's something that's really important to get the hang of and understand. I'm gonna talk a little bit more about sort of like conceptual stuff about what different kinds of merges are, or different ways to combine data sets are. But it's also going to be Python specific, of course. So yeah, let's just dig into it. There's one thing. I'm going to use a package called matplotlib-ven to make Venn diagrams. It's just for visualization, so you don't actually need it yourselves, but if you want it, then you can install it by going into your terminal and writing pip install matplotlib-ven. You can also use a Jupyter Magic function, which is just this percentage sign, and then Python will help you, or the notebook will help you install it. Yeah, so what I mean by that is so you run this code block like this without having it commented out. Now in my computer, it would hopefully just tell me that I've already installed it. So there's no need to do that for me. But for yours, then the text will be different. And then you will need to restart your kernel and run everything again. Yeah, okay. The other packages we need are pandas, of course, because we're going to be doing data. We're also going to be doing some plotting. So we import matplotlib and set some base parameters. And then we'll use this Venn talk because we have basically two circles in our Venn diagram. We'll get to that later. So first a bit conceptual stuff that we need to get through to understand sort of what's happening. If you understand all of these words and just want to know the code, then skip forward a few minutes. But otherwise I'll try to go through it. Concatenating data, you can also call it appending, is sort of when you have data of the same variable. So the example here is going to be income data for different municipalities for different years, and maybe you have two data sources, which one is all the municipality in eastern Denmark, and the other data source is all the municipalities in western Denmark. And you want one data set for all the municipalities in Denmark. Then you want to concatenate the data. So you have sort of a list of municipalities and their income, and a list of municipalities and their income from western and eastern Denmark. And then what you do when you concatenate or append is sort of just to stack the rows on top of each other. So you have all the municipalities and all their incomes in one long data set. And this works if the columns are the same variable. So if you have income data and your ID variable is the same, of course. Merging is a bit different. That's when you have two data sets with the same IDs. So you maybe have two data sets that both contain the same municipalities, all the municipalities in Denmark, but one is income data and one is employment data. And you want to have to be one big data set with just municipalities, and then a row, a column for the income and a column for the employment. That's when you want to merge, and then you will merge on the sort of the municipality. So for each municipality, you will have the income from one data set and the employment from the other data. There are many different kinds of merges depending on which observations you want to keep. So first I'll just go through the one-to-one methods, And one-to-one basically just means that your ID variable, for example, municipalities, the thing you're merging on, is there's only one of those, one unique one in each data set. So you expect, or you sort of assume, that in your data with municipalities in Denmark, then you don't suddenly have two observations that are both Copenhagen or something. Because then the merge don't work as you expect it to. So assuming that you have one observations for each identifier, and you can, of course, your identifier can be one variable, it can be municipalities, but it can also be municipalities and years if you have sort of a data set with multiple rows for each year for each municipality. Yeah. So an outer join is sort of where you take everything from both data sets. So, because of course maybe you have Danish municipalities, income data, employment data, but sometimes in the real world data is messy. So maybe some of the municipalities are not in one of the data sets, and some of the other municipalities which are in the first data set are not in the second data set. And what you do when you do an outer join is just to say, okay, fair enough, the data sets are incomplete, but I want all the available data. So let's say Copenhagen is not in the employment data set, for example. And then when you merge them together with an outer join, then you say, okay, fair enough, we don't have employment information for Copenhagen, but we still have the income information. That's sort of what happens when you do an outer join. You just keep the Copenhagen observation or Copenhagen row, and you just leave blank as a name and not a number any information that you don't have, but you keep the information that you do have. An inner join is the exact opposite. There you say, okay, I only want to keep the observations where I have full information. So only if Copenhagen is present in both datasets, then I want it to be in my merged final dataset. The left join, you can also do right join, but that's just the opposite of a left join. Left join is just where you say, okay, I have one dataset, which is sort of my main or my starting point dataset, and I just want to have the observations that are in that dataset. So if there are any observations in your second dataset, then any observations in this dataset that are not in this dataset, the first one, the left one, then you want to drop those, then you don't want them. And also if they are missing any observations from the right dataset, then you still want to keep them in the left one. You'll just have a missing observation, a missing value for your, so if this is income data and this employment data, then you just have a missing employment data. And of course, if you're keeping observations within both datasets, you will have missing values. So this has all been one-to-one merges. You can also merge datasets where you do a many-to-one or many-to-many merge, which basically just means that you may have datasets for the municipalities where you have one municipality, but you have multiple years per municipality. If you then do a merge on municipality, then for each municipality, for example, Roskilde or something, then you will have multiple observations for Roskilde because you'll have all the different years, and that means you have many instead of one that you're merging on. If you're just doing a many-to-one merge, then that could be like you have yearly information on the income for each municipality, but maybe you have some geographical information like the area of the municipality, the square miles, how big is the area, and that will not be year dependent, so you only have one observation per ID. Then you can do a many-to-one merge, and then you will just have that one number for each municipality will just be repeated many times. The problem happens if you sort of do a many-to-many merge, because then you will have repeated observations for everything, because if you have two data sets which have both municipality and years, and you only merge on municipalities, then sort of for each municipality year combination in your left data set, there will be all the available years. It will create an observation for all the available years in the merged data set. I think that's easier. I'll show you how it looks later. Yeah, and there's also a pandas guides on combining data sets if you want to dig more into it. Okay, so now we read in the data. We just read it in as our stored CSV files. So I've saved the data folders in a folder here. And then we can just read them in, and you use the data blah blah slash the dataset names, and then you read them. That works fine. If you because I just copied the datasets from another lecture. If you just want to get them directly, then you can use this dot dot to go outside the folder. That means basically going into the parent folder of the folder you are in. So I can show you that more directly. Should maybe have opened that before. Yeah. So right now we are inside this folder, and in a previous lecture called data load, clean and save, we have actually used the same datasets before. So what you are saying to Python when you write just close it. When you write dot dot is basically just to say, okay, go into the mother folder of this folder. So that will be this folder. And then you go into a new folder. So I've written data load, clean, save, data, and then the other data sets. So that's what I've written here. To data load, clean, data, folder. Yeah. That's just to show you sort of how to navigate folders using Python. But it's a copied data set, so it's the same data set. Yeah, so let's see what we have. First I want to show you, so this is the employment data, so the employment shares in each municipality. First I want to show you quickly how to concatenate data sets. It's sort of, in a lot of data it doesn't really make sense, but sometimes it do. Maybe you'll have like an updated year or something. So we just create a scenario where it makes sense. So first we extract how many observations we have in our data set. So you might remember that this shape sort of gives the shape of the data set, number of rows and number of columns. So if you take the first element of that tuple, then you can have the number of rows basically. And then we just split the data set into two data sets. So we take the first half and then the second half, and then we can see that now the data set is sort of split into two, and then you can just concatenate them using this concat. So you write pd.concat, and then you can have a list of the data sets. You can also have, you don't need to have two, you can have like 100 data sets or something, and then you create a new data set, which in this case is exactly equal to our original data set input, because we just split it in two and then we concatenate it again. Yeah, so concatenating is pretty straightforward. Issues can always arise when doing data cleaning, but yeah, it's a relatively straightforward to concatenate. There's also a Python function called append directly, which does a very similar thing. I think it's easier to just know concat. It's a bit more flexible. Yeah, merging datasets. So now we're going to look at having two datasets with different variables. So the employment dataset and the income dataset. The central command here is pandas.merge your left dataset and your right dataset. Then on is the variables you want to merge on. So here we're merging on municipality and year. And then how is the method. So method is outer, inner, or left, typically. There's also, you can go to the documentation of merge, and then you can see you can also choose cross, where you're sort of getting the Cartesian product from both frames. I've never done that, but there are other options. I think you would mainly use these, and you'll probably not often use right, unless you just change the order. That's not really important. And then there are some other options you can go through when you need to merge stuff, and maybe you need a few extra options. I generally think that the pandas documentation is relatively nice, and it has examples in the bottom, which are also really nice, because sort of one thing is reading this and trying to understand it, but another thing is just see what works and how it works. Yeah. So first we have a look at our data set. So we can see that in the employment data set, we have from 2009 to 2021, and we have 99 unique municipalities. So what we're doing here is calling input.year unique gives the unique years. So just taking, because in the data set there are like repeated years, because they're repeated for each municipality. So we just want to extract like what are all the available years in this data set. And then we take the length of how many unique municipalities are there. In the income data set, we can see that we only have from 2008 to 2021. And that's because I went in and deleted... So we have from 2008. And I went in and deleted 2008 in the employment data. So in this case, it's not because it's actually not available. It's just because that's sort of... it's good to have a roadblock in there, so I can show you what happens when your datasets don't line up. Okay. You can also sort of see that directly here by finding the differences. So you say you loop through the unique years that are available in the income dataset and the unique years that are available in the employment dataset. So you say I in all the available years in the income data set, but you only want to keep it if it's not in the if that year is not available in the employment data set. And then you get out that 2008 is missing. And for the same, you can do sort of the opposite, just using employment here and income here. Then you can see that Christiansø is in the employment data, but it's not in the income data. Yeah. And this, of course, a problem when we're merging. Oh, not a problem, but it's something to be aware of. So now we're getting to the Venn diagrams. So we have a bunch of common observations where we have the same municipality and the same years, which when we merge them together, that was sort of, they are nice because it's same information. But then we have the problem that in the Embl dataset you have Christiansø, which is not available in the income dataset, and in the income dataset you have all the observations from 2008, which are not available in the common in the employment dataset. Yeah, so this sort of shows the the union of available data in the datasets. Okay, so now we'll visualize and also show you how to do an outer join. So basically what an outer join means is that you include everything. So you include Christiansø and you include 2008, despite it not being in both datasets. Yeah, okay, so, and I should probably note that this Venn code, if you want to understand it, then take some time to understand it. It's not really a main thing. Like, I haven't used it except for doing this course, and say for sort of visualizing joins. So I won't spend much time on it. Basically what you're initializing the Venn diagram, then you have the sizes of the different circles, or sort of where they're placed, and you set labels and you give them text, and then this code just sort of makes the font size a bit smaller so they can fit. Yeah. So now we do an outer merge using pandas.merge, left dataset, a right dataset, the years we want to merge on, and then we say outer. So we can see that the number of municipalities become 99, and the number of years becomes 14. If we go back to where we printed what were available in both datasets, then we see that we had 99 municipalities available in the employment dataset, but only 98 in the income dataset, but we have 99 in our new dataset because it's an outer merge, and we also have all available 14 years. Yes, 14 years in our new dataset. So how does that look exactly? So if we want to look at the data observations for those observations where the year was missing in the, can't remember, the employment or the income data set, and where the municipality was missing. Then we can see, okay, for that part of the outer join data set, then we have employment information on Christiansø, but we have no income information. It's just nans. And for 2008 observations, so we're only plotting like the beginning, so you can see if you plot more, then you can see you have more 2008 observations. You can also maybe print out how many observations do we have where we have missing observations. That's 111. Yeah, but for all the 2008 observations, then we have income information, but no employment information. This is fine, as long as we're sort of aware of it. Yeah, but you can sort of, if you forget it and then you do some statistics where you're not taking into account that some of the information is missing, then you can get into trouble and unexpected behavior. Yeah, be aware. PD merge does not check whether the variables you're merging on are unique. So we've been doing one-to-one merges, but pandas does not actually check whether or not it's a one-to-one outer join, or if it's a many-to-many or a many-to-one. You can ask pandas to do that for you by using the validate argument. So that's just adding another argument when you are merging, saying validate, and then I say, okay, I want to do a one-to-one merge. And then Python says, fine. If you try to do something that's not a one-on-one merge, for example, if you're merging on the municipality only and not year, then from this data set we have multiple observations per municipality, so it's not an unique identifier for each observations. Then this validate thing will cause an error. So we try to do it, and then we get the exception that no, it didn't happen. So if I pull it out of this try stuff, then we can see the actual error that you're getting. You're just getting a merge error because merge keys are not unique in either left or right data set, not a one-to-one merge. Which, as we saw earlier, if you had year here, then it would be fine. If you want to do a many-to-many merge, which you don't want to do, but I want to show you what happens, then you can just remove the validate, or you can say I'm doing a many-to-many. Python doesn't actually check anything in this case, but yeah, then you're saying it explicitly. What happens when you do a many-to-many merge? So if we remember our data set, if you look at the impl, then you have Copenhagen. Let's just sort it. Municipality. Right here. Okay. Yeah, I want to look at Copenhagen, just so it fits. Copenhagen. Then you can see for Copenhagen. For Copenhagen we have it's working. For Copenhagen, we have multiple observations because we have multiple years, and the same is true for the income data. Multiple observations for each year. So if we're only merging on municipality, then we're doing a many-to-many merge, and then that will mean that for each Copenhagen observation in the income data set, then we're merging all the available rows in the employment data set. So we'll have for each municipality year combination, we'll have all these rows that are combined with it. So that's what's happening here. And then you have 2 year variables. So this will be a year in the employment data set, and this is the year in the income data set. And then you can see for this first observation with Copenhagen in 2009 with the employment information, then you will merge on all the available income information. And then for 2010, then you will repeat that exact income information. So you can see here that you're starting 2008 and you have the exact same values as you started with. And this is basically why a many-to-many merge is not wanted. Because you have rows, a lot of rows with repeated data, and you don't really get anything like functioning out of it, and it's mostly just confusing. Because you're sort of, what you're really interested is this row where you have the 2009 data on both employment and income, and then you want this row with the 2010 data, and so on. So not recommended, but I just want to show you what happens in a many-to-many merge. So inner join. What happens here? What happens, as I said, is that you sort of only keep the union of observations, so observations that are in both data sets. So you drop Christian Sø because that's no longer in the data set, or that's not in the income data set, it's only in the employment data set, so you drop it, and you drop all the observations from 2008. Yes, and how do you do it? You just say how equals inner. That easy, and then the PD merge is the same as before. And then this new inner data set, then you can see that your number of municipalities is 98, before it was 99, and your number of years is 13. We can see that the inner join does not contain any rows in both data sets. Yes, and this is just sort of checking. So that's what happens with an inner merge. Typically inner merges are a bit cleaner. You're dropping data, which is never nice, and you should always be sort of very focused on, or sort of aware of what data you're dropping. You shouldn't just say, I'm doing an inner merge, I don't care what I'm losing. You should know what data you're dropping in a good data analysis. But the nice thing about it is that sort of, if you're doing regressions or something, then you'll anyway have to drop all the observations where you have missing observations, missing data. So you get a lot cleaner data set out from having sort of no missing data in any values. Left join is another common thing to do, and you can also see it as a many-to-one join. It sort of depends on how many observations you have in your data set. Left join is sort of, it's very nice if you have sort of one main data set with all your observation and your sort of targeted sample, and then when you do a left join, you sort of say, okay, this is my sample, I have some information from this data set, so for the people or the municipalities that I'm looking at, if the data set is available, then I want, or if the data is available for those people or those municipalities, then I want that data. And otherwise I don't want it. I don't want to increase my sample because sort of it's a weird sample selection that they're in this weird data. So in this case, we'll do it as a many-to-one. So we have the our inner data set, which is just this merge data set with both employment and income data for multiple years for each municipality. And then we'll merge on an area data set, which has the area in not square miles, it's square kilometers. But it only has one observation per municipality because area doesn't change over time. Maybe you move municipality lines, but we assume that doesn't happen. Yeah. So, and the way you do it is just PD merge inner area on municipality only, and you want to do a left join, so you're keeping all the observations that are in inner. You could also add the validate, but now you would have to validate that it's a many to one merge. For example, if you said 1 to 1, that would cause an error. But you don't need it as long as you sort of know which data that you're using. Yeah. So we print it out, and now we just get this kilometers. Maybe you can even. So if we just sort the values by municipality, then you can see that sort of for Aabenraa, for example, then the square miles is sort of just repeated for each observation, because you have multiple years, but the area does not change over those years. Yeah, and you can see that we're sort of preserving the number of observations from the inner data set, not from the area data set. The area data set is basically broadcasted out onto the bigger inner data set. Yeah, and then there's a visualization. So left join, you have the inner data set where you have you include any observations where you don't know if they are square miles. If they're so the order of things is a bit different here, but it's because in the area data set you don't have the Christiansø again, I think. And you have that. You have Christiansø, but you don't have it in the inner data set because that was an inner join, and we didn't have it in the employment data set. We don't have it in the income data set. So you don't have it in the inner data set. You do have it in the area data set, but it's dropped because it's not included. All municipalities in the inner data set are also in the area, but maybe if you had some municipality in the inner data set, for example, I don't know why there should be a municipality in this data set that's not in that data set, but if there were, then that would still be included. You would just have missing value for area. It's important to sort of check these things after a merge or before a merge. So here we're checking for MNM. So for all the unique municipalities, we're storing it. If they are not, so all the unique municipalities in the inner data set, we're storing them if they are not in the area. If they're not in inner, so this is just reverse. And then we can see that there are no municipalities in inner that are not in area data set, but there are the Christiansø one, which is in area, but it's not in inner, but it's dropped because it's a left merge, and the left data set is the inner data set. And then we can sort of assert, because there are no missing municipalities, then there will be no observations out in here in the red square, even though they would be included if there were any. There just aren't any. So we don't have any missing information on the square kilometers. Yes. An alternative function for left join is to use a function that's called join. The main difference between joining, and you can also do other kinds of merges using join. The main difference between join and merge is that join uses the index of the data set. Sort of pandas has this thing about so typically we're not using the index that much, we're just having it as a numerical index, but you can set a variable as an index. You can also have multiple variables as an index, and it can work kind of nice. And if you're working with indices, and multi-indices, then using join to merge stuff is really easy because it requires less information. Python will just sort of know that you're merging an index and stuff like that. So it can be quite nice. So it's just another tool in your tool belt, basically. If you don't have them as index already, then merging is typically easier. So yeah, we have the area dataset, then we have the inner and the area dataset, then we have to set the index to municipality and year in this case for the inner dataset and municipality. So now we can look at the dataset. So if you look at inner, then you'll see that its index is sort of now this information on the dataset, instead of just having a numerical index. And the same for area, that's just only the municipalities. And then when you call inner.join with another dataset, then Python will know, pandas will know that you're joining on the index, the common index variables. So you're joining on municipality. So this gives the same dataset as before. Yes, and this is just sort of a comparison with the other programming language. So SQL, which I think people in economics have typically used when they're using SAS, so the proc SQL command. You might experience that later. And in comparison to what we have been doing, then the way you would do a left join is you say select all the variables, that's what the stars mean, from EMPL dataset, do a left join with the income datasets on municipality, basically. Then you're saying, okay, the municipality in EMPL has to be equal to the municipality in income, and the year in both datasets has to be the same. So this is basically a left join on municipality and year between EMPL and income. And outer join is just the same, you just write outer instead. In Stata, then you have the command called merge, and there you have to specify explicitly whether or not you're doing a one-to-one merge or many-to-one merge or one-to-many. Stata is a bit more like strict on what kind of merge you're doing, but I don't think that's a bad thing actually, because it's important to be aware. So I also recommend using this validate argument to make sure that you're doing what you think you're doing. I think that's the most common sort of error in data science and data analysis, is that you're doing something. I mean, another area is you don't know how to do what you want to do, but once you've written the code, a common error is that you're doing something and you think it's doing one thing, but it's actually something else is happening because the data doesn't look quite as you expect. So it's important to do these validate stuff and print out your data set and make sure that sort of everything looks how you expect it to do. Stata can also do many-to-many. It will actually warn you, as I remember, when you're doing it, like, are you sure you want to do it? Because it's not a common thing, and you shouldn't do this unless you're like really sure that many-to-many is the way to go. There are some additional links, something to know about having missing values in dataset, how to sort of deal with that. I think the main thing is to be aware of why is the data missing. Is because it's actually just zero, or is it because it's not available, or sort of maybe the country didn't exist at that time, blah blah blah, something. You just have to be aware of it to know how to deal with it exactly. So all your calculations and all your numbers are sort of still representative and true from the data. And yeah, then you have comparison of, if you're very familiar with SQL, there's some comparison of SQL statement and the pandas group by stop here. I think that was everything for this video. Thank you for watching.